Welcome again to FlippedHarber for Calculus. In this video we're going to be taking a look at using the derivatives of trigonometric functions. Our objectives for this lesson are to learn how to apply the derivative rule for sine of x, cosine, tangent, secant, cosecant, and finally the cotangent of x. I want to give you a handy rule to help you remember how to keep these straight, and then we're going to take a look at applying some of these rules. Our outline for this video, we're going to take a look at taking the derivative of sine of x the hard way. Now we're not going to do it this way for all of these. I'm going to show you the process that's involved in trying to figure these things out so that you can appreciate the fact that we're just handing you these rules. And then we'll take a look at the rule for cosine x, tangent x, secant x, cosecant x, and cotangent x. So let's start by talking about the derivative of sine x. Now remember, the derivative is a fancy word for the slope. And also remember that if we don't have a rule for something, in order to take the derivative, what we need to do is use a limit. So again, we're taking the limit as h goes to 0. We're plugging x plus h into the function minus f of x. Okay, now I'm not going to expect you to do this, but I want you to appreciate the work that's done to create these rules. So in order to do this, what we've got to do is start to use some of our trig identities. Remember the sine of two angles added together. Remember, sine operates on angles, so we've got to think of x and h as being angle values, generally in radians, because that's how you should have your calculator set even. So this is the sine of alpha plus beta, if you remember your trig identities. So that sine of x plus h is what gives us this whole expression in our fraction, and then minus the sine of x. Now if we do some algebra to this, we can shuffle things around. We've got sine of x appearing in a couple different spots, so those get moved together. So when we factor out the sine of x's that appear in two terms, this is what we get here. And now we need to try to use some limit rules in order to simplify this sum. So we're going to take some limit rules on this sum. This is a limit of one thing plus another thing. So we get to take the limits separately, and when we take the limit of a product like sine of x times that fraction, we can again break that down and find the limit of each of these parts. Now when we do that, it turns out that a lot of stuff either goes to 0 or it goes to 1. Now which one goes to 0, which one goes to 1? Well, this second limit right here goes to 0. Okay, I'm really not going to get into why, because let's face it, you really don't care. But that limit goes to 0. One of the best ways to prove that to yourself would be with a table. And this last limit actually goes to 1. And again, kind of the best way to prove that to yourself so that we don't have to get into some heavy-duty math is to just make a table, because tables are, a great way to figure out any limit. So since that second limit goes to 0, that whole term in front of the plus goes to 0. And since that very last limit goes to 1, that means that all we're left with is that limit as h goes to 0 of cosine x. There's no place to plug in for h, so we just throw that limit away, and it turns out that we get cosine of x. Now if you remember where we started, that was the derivative of sine x. Now I'm not going to bother to go through this whole process for the cosine of x, but you can appreciate what would have to be done. The whole limit as h goes to 0. But it turns out that the derivative of a cosine x is just a negative sine x. The derivative of tangent x, well, one good way to actually figure this out without doing that limit work would be if I tried to take the derivative of sine x over x, because that's what the tangent is equal to, the sine of x over the cosine of x. That's what the tangent of x is equal to. So I could actually figure this one out by using my quotient rule and my two new rules for the sine and cosine. But if you do that, all that hard work, which I think is actually part of your homework, we find out that the derivative is equal to the secant squared of x. The derivative of the secant of x is equal to the secant of x times the tangent of x. Now, I'm going to warn you that one of the most common mistakes that I see is people forget just to write this little x right there. That secant is an operation that has to have something to operate on. If you forget to write that x, you're actually saying that it's the secant of the tangent. So don't forget that term, and that's really going to become important later as these things get a little more complicated. The derivative of a cosecant x is a negative cosecant x cotangent x. And our last one, the derivative of a cotangent x, is a negative cosecant squared x. So, hopefully you've taken the time, you've paused the video, you've written all of these rules down. And really the best way to do this stuff, to remember what all of these individual derivatives are, is to just use them. Just practice, practice, practice. Now, I always found this to be handy. I just want to point this out for you. It's a good way to, kind of check yourself at the very end when you're trying to do a problem. If you take a look at the derivative of sine, the derivative of secant, the derivative of tangent, those are all positive. But when you take the derivative of cosine, cosecant, or cotangent, those all end up as negatives when I take the derivative. So I always keep in the back of my head that the derivative of some trig function is a negative. So the derivative of a is negative. I just always found that to be useful. Now let's go ahead and look at applying some of these rules. This is just basically fitting these new rules into things that we've already done. So I want to take the derivative of x squared times the cosine of x. Now remember, we've got a little operation right here. We've got multiplication happening right there in between. So I've got to use my product rule when I do this. So when I use my product rule, I have 2x cosine x. That's the derivative of the first part times the second part, plus x squared times negative sine x. So that's the first term, first factor I should say, times the derivative of the second. So the derivative of the cosine x is negative sine x. And now what I want to do from this point forward is just try to simplify it, see if maybe I can factor stuff out. Now I could factor an x out of here. I could. I really don't care. You generally won't see me factoring out things like x's. I do tend to factor out things like e to the x, or if I could factor out some sort of trig function. I generally don't factor out an x from both of these terms, but if you feel like it, you can. Now here I want to take the derivative of the tangent x over the secant x. So I look at this big picture, what I've got is a quotient. So I'm going to have to use my quotient rule, the whole high over ho rule. And I'm going to start by taking ho d high minus high d ho all over ho ho. So I just kind of blindly follow my rules. I'm not worried about what's going to happen next because I'm just going to go step by step. Deal with one step, and I'll worry about the ramifications. I'll worry about the work that I have to do later. Okay? Don't sit there and fret about what you have to do next. Take care of one step at a time. So I've got that secant squared on the bottom, so I can go ahead and cancel out a secant everywhere in this fraction. So I'll factor out, or excuse me, cancel out a secant there, and one of these secants on the bottom. Obviously I can turn that tangent times tangent into a tangent squared, and where did I get that one? Well, you should always check your trig identities, and I've got trig identity sheets for you if you need them. Okay, if you need a trig identity sheet, just let me know. I've got them. I can just print them out. It's going to be the exact same trig identity sheet that you saw in pre-calculus before or in trig before. So secant squared x minus tangent squared x is actually equal to 1. So 1 over secant x is equal to cosine x. Well, boy, that's a really simple derivative. And if I remember right, cosine x is the derivative of something. Well, it's the derivative of sine x. And we actually could have simplified way up here and actually asked ourselves, what does the tangent of x divided by secant x equal? And maybe we could simplify stuff up top before we take the derivative. But I wanted to take a look at using these rules with the quotient rule. All right, so let's do another product. I've got e to the x times cosecant x, so I've got to use my product rule again. The derivative of e to the x is e to the x, and the derivative of cosecant x is negative cosecant x cotangent x. Again, most common mistake I see is people forgetting to write that x that cosecant is operating on. So I'm going to go ahead and pull out e to the x. I'll factor out a cosecant x also, and I have 1 minus cotangent x. Now again, I should probably check my trig identity sheet. I didn't find anything for 1 minus cotangent x. So if I don't find a trig identity, just leave it like that. Okay, that's it. I've showed you all 6 of those rules. I've showed you some examples, so now it's time for you to get to work. So I'll see you in class, and I'll see you online.